Welcome, everyone. It gives me great pleasure to invite you all on behalf of the Terry Lectureship Committee to this fall's Terry Lectures. In the true spirit of the bequest, to promote and foster assimilation and interpretation, building upon the truths of science and philosophy, our speakers this year are Joel PRIMACK and Nancy Ellen Abrams, who will be talking to us broadly on the cultural context of cosmology and will offer insights into our place in the cosmos. What is unique about this year's Terry Lectures is that for the first time, we have two lecturers who happen to be a husband and wife team comprising of a scientist and a philosopher, engaged in a very vibrant, innovative, and creative collaboration. Joel PRIMACK is professor of physics at the University of California at Santa Cruz. He has been at the forefront of research in the formation and evolution of galaxies and the nature of dark matter that makes up most of the mass in the universe. Starting out as a particle theorist, having made fundamental contributions to what is now called the standard model of particle physics, Professor PRIMACK began working in cosmology and became a leader in the new field of particle astrophysics. He is one of the original proposers of the theory of cold dark matter, which has become the basis for the standard and modern picture of structure formation in the universe. Aside from his scientific contributions, Joel has had an abiding interest in science policy, in particular on the issue of nuclear disarmament. He has co-authored an influential book titled Advice and Dissent with Frank von Hippel. He was instrumental in setting up the Congressional Science Fellows Program. Joel and Nancy were also part of the official American delegation to Moscow that helped negotiate the decommissioning of nuclear reactors in space with the former USSR. Nancy Abrams read history and philosophy as an undergraduate, followed by a law degree and further qualification in international law. Finding the practice of law to be somewhat restrictive, Nancy moved into the arena of science policy. She has long been interested in the role of science in shaping politics and has worked for the Ford Foundation and the US Congress's Office of Technology Assessment. She helped develop a novel procedure, scientific mediation, to help government agencies make wise policy decisions in areas where the relevant science is crucial, yet rather uncertain or controversial. Also interested in science's border with myth, Nancy Abrams has worked as a scholar to place the discoveries of modern cosmology into a cultural context, and as a writer and songwriter to communicate their possible meanings at a deeper level. The 2010 Terry Lectures will also, for the first time, be a multimedia presentation, unlike anything we've seen before, including visually stunning astronomical videos based on real observations and cutting-edge simulations of the invisible universe from Joel's group, set to Nancy's music. These calculations have been performed with the state-of-the-art supercomputing facilities. In today's first lecture, titled The New Universe, Nancy and Joel will explain the profound role of a shared scientific understanding of the universe with a strong sense of our place in it. We look forward eagerly to this journey. Before we start, I would like to request all of you to turn off your cell phones or beepers. Thank you very much for that. Nancy, Joel.
Thank you very much, Priya. That was certainly one of the most eloquent introductions we've had, and certainly the most stunningly well-dressed. Well, welcome everyone to this series of lectures, Cosmic Society, and the first talk, which is The New Universe. In this series of lectures, we're going to do two major things, and they're going to be intertwined. The first is that we'll present the new scientific picture of the universe as visually as possible. And the second is that we'll interpret what the discovery of this astonishing new picture of the universe may mean for our lives, and discuss how it could help the Earth's peoples become a cosmic society. That is, a society whose members have come to terms with their place in a dynamic, evolving universe and are capable of thinking in and acting for the very long term. Every culture that anthropologists have studied has had a cosmology, meaning a story of how the world began, how humans came to exist, and the role of invisible forces in these events, usually spirits ancestors or gods. Of course, their notions of the universe were not what anyone today would consider scientifically accurate. But with what we've gained in this scientific age, we've also lost something important. We may be the first major culture in human history to have no coherent idea what our universe looks like, or how to think about how we fit into the big picture. In those high places of human consciousness, where cosmic mythologies carried our ancestors, there is, for our high-tech, fast-paced world, just narrative darkness. Many religious people still believe that Earth was created as is a few thousand years ago, while many scientifically educated people think that Earth is just a lonely rock in trackless space. Who's right? Neither one. Both pictures are wrong. Meanwhile, our global problems are accelerating. Religiously justified violence, exhaustion of planetary resources, global overheating, economic chaos, etc. In these lectures, we're going to suggest that there's a connection between our lack of a shared cosmology and our increasing global problems. Very few people realize this, because in modern life, astronomy seems to have very little relevance. People think of astronomical discoveries as fodder for a news article that's fun to skim, perhaps, or a great topic for 5 minutes of dinner party banter. But frankly, there's just no widely understood connection between what's happening in distant space and us right here. But the new cosmology actually makes it possible at last to understand how the universe fits together on all size scales, including our own.
The joke among scientists used to be that cosmology is the science where the ratio of theory to data is nearly infinite. Lots of theories, almost no data. But in the last 2 decades, this ratio has completely flipped. A flood of new data has eliminated every theory but one, and that one not only fits all the data, increasingly, it's predicting the results of observations before the data comes in. The more we understand the theory, the better it fits the rapidly accumulating data. The technical name for this theory is Lambda CDM. Lambda for dark energy, and CDM for cold dark matter. It tells us that everything we can see with the greatest telescopes on and orbiting Earth is only half of 1% of what's really out there. The stars, the glowing gas clouds, and this is one of the pictures that just came down from Hubble Space Telescope with the new camera, Wide Field Camera 3. This shows the glowing gas cloud in Carina in optical and ultraviolet, and this shows exactly the same thing, but now in infrared, another capability of this new camera, so that you can see through the dust that was obscuring where new stars are forming. So that, and also this wonderful new picture, again with Wide Field Camera 3, of a planetary nebula. This picture of the planet Saturn, taken out near Saturn by the Cassini spacecraft. This actually shows 2 planets. I hope you can see. There's Earth, seen through Saturn's rings. So all of these pictures, and also this wonderful picture of the Hubble Ultra Deep Field, showing many, many galaxies out to the cosmic horizon. All of these images represent just 0.5% of what's actually there. The universe as a whole is controlled by 2 invisible things whose tango with each other has created the galaxies, and which are the galaxies which are the only home for the evolution of star systems and life. The 2 invisible substances are dark matter and dark energy. And it's those together that are the basis of this modern theory of how the universe works and how it evolved, the double dark theory. Dark matter and dark energy were unknown and even unimagined until the 20th century. With dark matter collapsing the galaxies into being and dark energy accelerating them apart, the evolving universe has turned out to be far more dynamic than the idea of empty space scattered with stars and planets. The end of the 20th century and the beginning of the 21st has been a golden age of astronomy and in particular cosmology. In a very real sense, we have discovered the universe. What is emerging from modern cosmology is the first story of the nature and origin of the universe that might actually be true. The difference between our new scientific picture and all earlier creation stories is that the modern scientific story is supported by an immense amount of evidence. What's more, this is the first cosmology ever created by collaboration of peoples from different religions, races, and cultures all around the world, all of whose contributions are subjected to the same standards of verifiability. The new universe excludes no one and sees all humans as equal. There is a revolution in scientific cosmology happening now that may open the door to a believable picture of the larger reality in which Earth, our lives, and all of our religions are embedded. This picture of the universe could become the foundation of a cosmic society.
Now, what exactly is a picture of the universe? Here's an example from ancient Egypt. Let's simplify that just a little bit. In this picture, the earth is flat, and it's a god named Geb. The heavens is his sister and lover, the goddess Nut. They were born locked together in an embrace and were separated by the god Shu, their father, who represented the air. They longed to come together again, but Shu would hold them apart and thus maintain the creation, only as long as the Egyptians performed their rituals properly. So Egyptians felt that they were upholding the cosmos literally, and major spiritual and ethical implications followed. They understood the everyday world as being embedded within an awe-inspiring but mostly invisible spiritual cosmos. The Nile, for example, flowed from the spiritual world onto farms. The lives of the spiritual beings gave meaning to life here. The ancient Egyptians had a rich and satisfying explanation of life, nature, and the gods, even though the nature part was far from accurate by modern standards. Now, much later, in ancient Israel and Judah, the three-part flat earth cosmos was still unquestioned, but the parts were no longer gods, as you can see. But now they were inanimate earth, air, and firmament. For the Hebrews, there could be only one God. But then came the first great cosmological shift. It occurred when the ancient Greek imagination burst out of this effectively two-dimensional flat-land Earth of Genesis to the three-dimensional universe. The Greeks realized that Earth is not a pancake, but a sphere. Now, by the Middle Ages, educated people from the Middle East and North Africa across Europe all the way to Scandinavia had come to believe that Earth was a sphere at the center of a spherical universe. Everything revolved around the Earth. Nested crystal spheres carried the moving planets, and the outermost sphere carried all the fixed stars. The whole universe rotated around Earth once a day, and outside the sphere of the stars was heaven. God had placed the spheres exactly where they belonged in a great chain of being, and the place of every creature and institution on the earth was part of this downward continuation of a cosmic hierarchy. Thus, it was considered blasphemous to question the hierarchy or the place God had chosen in it for you. This cosmology both explained and enforced the social rigidity of the medieval world. But although it was wrong astronomically that Earth is the center of the universe, it was right psychologically. The universe must be viewed from the inside, from our center, where we really are, and not from some perspective on the periphery or outside. In the medieval picture, just as in the Egyptian picture, the whole physical world was surrounded by a spiritual cosmos whose doings gave meaning to what was going on here. The second great cosmological shift was the Copernican revolution, which began when Copernicus proposed in 1543 that if the sun, rather than the earth, were seen as central, it would be easier to understand the motions of the planets. Galileo, Kepler, and Newton completed the job, and the medieval picture of the universe was replaced by what we now refer to as the Newtonian picture. In the Newtonian picture, Earth is not the center of the universe, but moves like the other planets, orbiting our star, the Sun, in a universe where no place is special or central, least of all ours. This intriguing drawing by Escher really gets across the idea of space as an endless grid where no place is any different from any other. There was no longer a place where the physical became the spiritual. It was now physical all the way out, possibly to infinity. This is the universe that the great novelist D.H. Lawrence once described as a dreary on and on without any meaning. With the Newtonian picture of physical reality dominant around them, religious people have often felt faced with a choice: deny the validity of science or accept it, but believe that there are two kinds of reality, the spiritual and the physical, with spiritual reality not constrained by the laws of physics. Unfortunately, in such a dualistic reality, it becomes possible to believe in science and still believe in almost anything else. Well, we who are alive today have an extraordinary opportunity, which, as you can see, has only arisen twice before in the history of Western civilization. And that's the opportunity to see reality afresh through a new picture of the universe. We are the first humans privileged to see a face of the universe that no earlier culture ever imagined. Religious cosmologies like those of Egypt in the Middle Ages may not have been factually correct, but they offered guidance about how to live with a feeling of belonging in the world. Modern scientific cosmology says nothing about human beings or how we should live or feel. It aims to provide scientific accuracy, not meaning or guidance. But today, we really can't afford to see these as separate anymore. The human race needs a believable picture of the universe that includes all of us. We need to connect the two different understandings of cosmology into a science-based appreciation of our human place in the modern universe.
Let's get oriented in the universe. What is our cosmic address? This is a map of our local neighborhood on progressively larger scales. It shows our, so to speak, geographic place in the universe. We're going to use this to orient ourselves. First, at the top, our solar system, where we live on the third rock from the sun, Earth. Each of the large shaded V's shows how the entire picture above is just a tiny point in the much larger scale picture immediately below. So our solar system is about halfway out in the Milky Way galaxy. It takes light about a day to cross the entire solar system, but it takes light 100,000 years to cross the visible part of the Milky Way. The Milky Way, in turn, is just a dot on the scale of the local supercluster of galaxies down here. It's out here in the boondocks. In the video I'm about to show, we're going to go on a virtual voyage from Earth past the local stars, out of the disk of the Milky Way, and then across our local supercluster to the Virgo cluster of galaxies at its center. The Virgo cluster is the densest concentration of galaxies for 100 million light years around. The stars that you'll see at the beginning of this video were mapped a little over 10 years ago. And the computer lets us move through the stars and the telescopic images of nearby objects. We're going to start facing this familiar constellation, Orion. The Milky Way arcs to the left of Orion. As we fly toward the sword hanging below Orion's belt, the sword comes apart because all the stars making up the sword are at different distances. We see that the center of the sword is the Orion Nebula, a gas cloud illuminated by the young stars forming there. Now, as we pass the Horsehead Nebula, we're 1,500 light years from Earth. The next glowing gas cloud that we see is another stellar nursery, the Rosette Nebula. But not all these glowing nebulae are stellar birthplaces. This is a place where a star died. It was seen on Earth about 1,000 years ago. This is the remnant of the Crab supernova. And you can see the neutron star at its center blinking 30 times a second. Until now, we've been inside the disk of the Milky Way, where our view of the center is blocked by dust created by explosions like the Crab Nebula. So let's rise up and out of the disk so that we can see the magnificent panorama of a galaxy like our own. As the galaxy recedes into the distance with the large and small Magellanic Clouds and other satellite galaxies, everything we see now is a galaxy. What's now come into view is the great galaxy in Andromeda, and in the foreground, a smaller spiral galaxy, Triangulum, or M33. As we go through this glowing gas cloud in M33, we're 2 million light years from home. Our goal in this voyage is the Virgo cluster, just coming into view on the left. But we're going to take a scenic route past some of the prettiest nearby galaxies that can be seen with an amateur telescope. Now I hope you can see that there's a chain of galaxies that ends here at the Virgo cluster, and in fact there are several such chains of galaxies that meet at the Virgo cluster. We're entering this chain here in the Ursa Major group of galaxies. We're going to ride down it toward the Virgo cluster. Before we were seeing largely spiral galaxies, but now we're starting to see big balls of stars, elliptical galaxies. This voyage ends at this large elliptical galaxy at the center of the Virgo cluster, M87 astronomers call it. There's a jet coming out of the center, and in the center there's a gigantic black hole with a mass 3 billion times the mass of our sun. Vast as it is, the local supercluster is just a tiny patch of the universe. There are many size scales in the universe, from bigger than galaxies, to trees and people, to bacteria, to atoms, and beyond. How can we grasp them all? We hope that this graph will help, and I'll try to help you understand it by going through it piece by piece. First of all, remember that 10 to the 10 is 1 followed by 10 zeros. That's 10 billion. And 10 to the minus 10 is a 10 billionth. Each of the tick marks on both axes are separated by 10 billion, by a factor of 10 billion. This is size, this is mass, or energy. One of science's most essential tasks is to rule out the impossible. The two sloped lines represent the borders of the possible. First, the upper line is dictated by Einstein's theory of gravity called general relativity. The relativity line tells you, for whatever size you choose on the x-axis, the maximum mass on the y-axis that could possibly be packed into it. For example, here is a neutron star. It's formed when, at the end of its life, a massive star collapses. A slightly more violent collapse contracts that neutron star so that it crosses the red line. And then it collapses away to no size at all, according to general relativity, a black hole. So general relativity excludes this entire part of the diagram. The lower line, in blue, is dictated by quantum mechanics. The uncertainty principle tells us that in order to probe objects on smaller and smaller scales, more and more energy is required, represented by the vertical axis of the diagram, mass or energy related by E equals mc squared. Thus, the region to the left of the white wedge of material reality is excluded. That means that there's a smallest mass. A smallest length is what I meant to say. We can't conceptualize anything smaller than the Planck length in our current understanding of physics. And here's why. The smaller the region, the more energy is required to locate something in it. To locate anything in a Planck-sized region requires so much energy that the region collapses into a black hole, which would instantly evaporate by Hawking radiation. And so the smallest size theoretically possible is the Planck size, about 10 to the minus 33 centimeters. It always helps to know where humans fit in. In the middle of the diagram is the human scale, about a meter high, or 2 meters, and about 10 to the 5th grams, about 100 kilograms, maybe a little bit less for most of us. The entire visible universe is surrounded by our cosmic horizon. So that's the largest size that we can see. Every place in the universe is the center of its own cosmic horizon, which is determined by the age and expansion history of the universe. Beyond the cosmic horizon, space is likely to be the same as nearby, with galaxies filled with stars like our own. But there's no way we can know for sure, because we can't receive any direct information about things beyond the horizon. Light cannot reach us from any region out there. Now, that voyage that we took to the Virgo cluster spanned a distance of about 60 million light years, which is about 10 to the 25th centimeters, right here on this diagram.
Well, not only is there a largest and a smallest possible size, but it turns out that they may be connected. So let's lay a serpent along the x-axis of the wedge of material reality. And we put the tip of the tail of the serpent at the Planck length and its head at the cosmic horizon. And now the serpent represents all the possible size scales in the visible universe. But the serpent, it turns out, is not lying flat like an x-axis. It's actually swallowing its tail. So we call this the cosmic Ouroboros. Ouroboros is a Greek word for tail swallowing. The cosmic Ouroboros represents the universe as a continuity of vastly different size scales. About 60 orders of magnitude separate the very smallest, the Planck length, from the very largest. There's the Planck length and the cosmic horizon at the head of the serpent. Now note that the human scale is right in the middle. So traveling clockwise around the serpent from head to tail, we move down from the cosmic horizon to the size of a supercluster of galaxies, the size of a galaxy, the distance to the Orion Nebula, the size of the solar system, the sun, the earth, a mountain, of course we're there in the middle, an ant, a single bacterium, a DNA molecule, an atom, and the nucleus of an atom. The scale beyond that of the weak interactions, which are carried by the W and Z particles, and approaching the tail, the extremely small size scales on which physicists hope to find massive dark matter, that's what the DM stands for, and on even smaller sizes, a grand unified theory, that's the GUT at the top. The concept of size scales is very useful not only for visualizing the universe, but for understanding ethics and spirituality for our time, but we'll return to this.
The cosmic serpent swallowing its tail, which is an image due to Sheldon Glashow, the Nobel Prize winner at Harvard. This represents the possibility that gravity links the largest and smallest scales and thereby unifies the universe. This actually happens in superstring theory, a mathematically beautiful idea that remains our best hope for a theory that could unify quantum physics and relativity. In string theory, sizes smaller than the Planck length get remapped into sizes larger than the Planck length. So there's a connection between the smallest and the largest. On different size scales, different physical forces control what happens. Everything has to be the size it is. It could never work if there were any substantial difference in size. Scale models don't work like the real thing. Size matters. So on large scales, gravity controls. On the size scales between mountains and atoms, it's the electromagnetic forces. Electricity, magnetism, the basis of chemistry. On the size scale of the atomic nucleus, it's the weak and strong interactions that control, along with electromagnetism. Now, we physicists have a very good theory that fits all the data from accelerators that includes the weak, strong, and electromagnetic interactions. This is the so-called standard model of particle physics. But there's no room in the standard model for most of the mass in the universe, dark matter. So we think that dark matter must correspond to forces on scales smaller than the ones we've talked about so far. So dark matter, and then as I mentioned, superstrings. Size matters. This idea that size matters was perhaps first understood by Galileo, and this illustration is from his last book, Discourses on Two New Sciences, which he wrote under house arrest. Galileo explained that no animal could be 3 times its normal height and stay the same shape simply scaled up. If the height increases by a factor of 3, the strength of the bones, if they retain the same shape, would just be proportional to their cross-sectional area, which would be 3 times 3, or 9 times stronger. But the weight of the animal would increase with its volume, and so it would be 27 times greater. And the bones, only 9 times stronger, could not support the weight of such a heavy animal. That's why an elephant can't look like a large gazelle. The bones have to be much thicker in proportion to their length. Do you suppose Hollywood understands that? And here's another example now, shrinking smaller. Everything has to be the size it is, or it doesn't work right. These familiar films illustrate the popular misunderstanding that things work the same way, no matter how much bigger or smaller than normal they are.
So what's our place? We humans are exactly, or almost exactly, at the center of all possible sizes. And this is true, here we are, whether the units used are centimeters, nanometers, or light years, so it's not an anthropocentric bias. If we use different units, the only difference is the numbers in the exponents. We would still be central, and we couldn't be anywhere else. If we were much smaller, we wouldn't be made of enough atoms to have the kind of complex consciousness that we have. If we were much larger, the speed of thought and other internal communications, which are ultimately limited by the speed of light, would be too slow. It's really only near the center of possible sizes that consciousness like ours can arise. And this tells us something about intelligent aliens if they exist. Because anywhere in the universe, they'll have to be approximately our size. Now, that doesn't mean 5 or 6 feet tall. That means somewhere between a redwood tree and a puppy. That's actually a very narrow sliver of possibilities. So here we are at the center of the cosmic Ouroboros, and the size scales surrounding us make up our conscious world, which we've attempted to show here in sunlight. It includes everything from the littlest creatures that humans can see with the naked eye, smaller than ants, perhaps gnats, up to about the size of the sun. And this section is what most people think of as reality. But as you can see, it's not all of reality. It's just a very special part of the universe for which we humans have awareness and intuition. This is our homeland in the universe. So Joel and I decided that we would give a name to this very special group of size scales, and we call it Midgard. In the Old Norse cosmology, Midgard was the human world. It was an island representing stability and civilized society in the middle of the World Sea, which was the Norse universe. The World Sea was large, and there was room in it not only for Midgard, but for the land of the giants and the land of the gods. This is an excellent description, metaphorically, of course, of Midgard in the expanding universe. Our Midgard is the island of size scales that are familiar and comprehensible to human beings. But beyond the shores of Midgard in one direction, outward, into the expanding World Sea, is the land of incomprehensibly giant beings, like black holes 1,000,000 times the mass of the sun, or galaxies made of hundreds of billions of stars. In the other direction from Midgard, inward, toward the small, lies a living cellular world, and beyond that, the quantum world. And these micro-lands are the evolutionary and physical sources of everything we are. That may not make them gods, but compared to us, they're more prolific, more ancient, universal, and omnipresent. Like the Norse Midgard, our Midgard is not isolated from these other lands in the world sea. It's connected, as the Cosmic Ouroboros illustrates. Midgard is everywhere in the universe. It's not a place. It's actually a setting of the intellectual zoom lens. So if you traveled to a planet, for example, in a distant galaxy, 1 billion light years away, and tried to get around, your Midgard intuition would be very useful, although of course fallible. But if you stay right here in this room and just change your mental focus to think about size scales outside Midgard in either direction, large or small, you find that your intuition becomes worthless. Without science, no one can and no one ever did imagine accurately how very small or very large things actually behave. Until the 20th century, infinity was thought of as an endless extension of Midgard. That's the way Isaac Newton pictured the universe. But now we know that once you jump off the island of Midgard, nothing is the same. The very laws of physics that control events change with exponential increases or decreases in size scale.
Physicists may think that the word physical means anything described by the laws of physics. But to most people, physical means solid, observable, unquestionably here. Physical is an intuitive concept, not a scientific one. Only in Midgard do objects satisfy people's intuitive sense of what's physical. Why does this matter? Because many people assume that if spiritual reality exists, as Nancy said earlier, it is separate from the physical universe. It transcends the universe and therefore does not obey the laws of physics. At least it doesn't have to. But the concept of Midgard undermines this belief, not by telling us anything about the spiritual, but by making clearer what the word physical means to most people. The largest structures inside the cosmic horizon, superclusters of galaxies, are actually expanding apart faster and faster. And in billions of years, they'll disperse. They're not bound together by gravity, but by our dot-connecting minds. So in some sense, they're not really physical objects. In the opposite direction of Midgard, toward the very small, there are elementary particles that are not particles like marbles, but rather quantum mechanical objects that are routinely in 2 or more places at once. The strange truth is that what we usually think of as physical is a property of Midgard, perhaps the defining property, and thus Midgard is what most people think of as physical. Beyond Midgard, however, lies most of the cosmic Ouroboros, most of the physical universe. Much of it is not physical in the common sense meaning of the word, but it is nevertheless real and governed by the laws of physics.
Transcendence is not some kind of jump to a reality beyond the universe, as if that even meant anything. Transcendence is what happens within our universe every few powers of 10. For example, on the atomic and the subatomic scales, human means nothing. There's no humanness to our atoms. Whether atoms are inside us, inside a rock, or drifting through space, it's all the same to them. We conscious beings understand that atomic behavior is fundamental to what we are. But on the atomic size scale, even inside our own bodies, we, as we think of ourselves, we do not exist. A human being transcends the world of atomic interactions. We are qualitatively completely different, although completely consistent. Each size scale is in seamless continuity with the next, and yet every few powers of 10, wham, there's a qualitative difference. A new phenomenon like temperature or consciousness comes into being, or a hitherto irrelevant law of physics takes control. Choppiness in the way complexity grows is characteristic of the entire cosmic Ouroboros. And so qualitative change every few powers of 10 is a universal pattern. As the physicist Phil Anderson says, more is different. So let's take a fast trip now through all of the size scales that it's possible to visualize, from bigger than superclusters down to the size of smaller than the atomic nucleus. And notice that there's going to be an arrow pointing to the size scale on the cosmic Ouroboros that you're seeing at that moment. Could Ouroboros thinking give us a new way of understanding ourselves? Exponential growth happens not only in sizes, but also in the complexity of human interactions. Everyone has probably noticed that although individuals can be kind, generous, and wise, people collectively, in the form of a committee, a city, or a country, are almost never kind, generous, or wise, even though the individuals who make up those groups may be. A recent newspaper headline I saw said, "Do the banks have no shame?" No, banks can't have shame. A collective cannot in principle feel or act like a human being because it's not human, even though it's made of humans. This may be hard to believe at first, but think of it this way. You are all made of elementary particles, but you don't behave anything like an elementary particle. Remember, you transcend them. We humans are the most complicated things we know of in the universe. Every one of us has multiple roles on all these size scales. We have our own self-consciousness. We have an identity as part of a family, as part of our tribe or community, part of our religion or nationality, part of the human species, life, Earth, and we are also part of the self-consciousness of the cosmos. Our sense of identity, of who and what we truly are, expands breathtakingly the moment we realize that we are all these things. With our new understanding of the cosmic Ouroboros, that different laws control events on different size scales, we can begin to bring our consciousness of our full selves, our potential, and our responsibilities into harmony with universal reality. The left side of this human identity Ouroboros represents the traditional layers of consciousness that we humans have developed through cultural evolution. But we're not finished. You will notice a gap between the religious and nationalistic identities on the one hand and species identity on the other. How can we get across this gap? How will we jump from traditional narrow identities that are endlessly in conflict with each other to a science-based identity that tells us that it's far more important that we are human beings than that we are part of any smaller subgroup? Modern biology has discovered that all humans are more closely related to each other genetically than are the members of any other species on the planet. In scientific cosmology, the challenge is to move out of Midgard. But for expanding our human identity, the challenge is to move into this central area because it represents the crossover from subspecies identity to species identity, from traditional religious cosmologies to a science-based appreciation of our true place in the universe. The jump to species identity is a qualitative jump. Of course, we have to keep expanding our consciousness to recognize our even larger identities as the consciousness of Earth and the cosmos, but these will follow much more easily once we have accepted that we humans are all in this together. In the Bible, Jacob has a dream in which there's a ladder from earth to heaven, and angels are moving up and down the ladder. And here are two beautiful traditional interpretations of that idea by William Blake and Marc Chagall. But in the modern universe, the real Jacob's ladder is the cosmic Ouroboros, and the angels going up and down are our own educated consciousnesses. Each of us can play all of our roles only if we adjust our consciousness to think in the appropriate way on each size scale. That is, if we move up and down the ladder. This may sound obvious, but it is anything but. Most people are still thinking about global politics or economics with understandings, moral judgments, and above all, a sense of time that are appropriate only to much smaller size scales, like a family or a community, a year, a single lifetime. They have no way of comprehending the thousands or even tens of thousands of years that things we are doing to our planet might last. The oceans are already destined to rise for 1,000 years, because of global warming, even if human beings all around the world completely stop putting greenhouse gases into the atmosphere tomorrow. Radioactive waste could be dangerous for 100,000 years. Extinction is forever. The science of cosmology aims only to understand the underlying principles and the history of the universe, not to change people's lives and not to challenge their religions. But once we find out about these principles, they necessarily change our thinking. We realize that we are governed by them, and so is everything. That's what universal truly means. A cosmic society needs a cosmology that's based on science, but gives us some guidance about how to live. Every traditional ethical system teaches how to get along with other individuals in the tribe, but now modern leaders, both political and corporate, control events on enormous time and size scales that no religious, political, or other tradition has ever even contemplated. Big changes in ethics are required for decisions on these scales. The principle of the cosmic Ouroboros could help us understand how groups of us can collaborate respectfully and productively with outside groups on all relevant size scales. No religion teaches how to do this, at least not yet. There are invaluable benefits available to people who claim their accurate and rightful place in the universe and adjust their thinking accordingly. To feel your roots stretching back through cosmic time is to know who you are and to see from a cosmic perspective. These are two abilities that our species needs to cultivate far more widely if we want to protect the chances for our descendants over the cosmologically long time.
In lectures 3 and 4 next week, we will come to the question of how to live in the new universe. The answer will be based not only on the new understanding of size, but on the subjects we're going to cover in the next lectures: the nature of time, what the universe is mostly made of, how it began, how we came to be here, and how we can create stories about these things that are powerful and bonding as well as accurate. Science is the foundation, but discovering and expressing its mythic meaning will be essential if it's going to have any real impact on our lives. We create a cosmic society not by zipping around the cosmos, but by expanding our thinking right here. In the lecture tomorrow, we will concentrate on the rare stuff we humans are made of compared to the rest of the universe, and the role of time in letting these ingredients interact. One of the main things that we hope to explain is that we're special or central in fundamental ways. Our bodies are midway between the largest and smallest possible sizes. We are made of the rarest material in the universe, heavy elements, stardust. Here's some stardust. That's a type 1a supernova explosion. We, like all observers, are at the center of our visible universe. And in the third lecture, we'll explain that we're living at the midpoint of time in 4 different senses. We hope to see you back tomorrow for lecture 2, and let me tell you that if you enjoyed the videos this lecture, you have a real treat coming next lecture. There are, I think, 8 major videos in next lecture. Thank you.